Let's investigate another textbook problem. Just kind of looking at the fraction here, right? And the numerator, both variables are going to 0. So the numerator is going to 0. Likewise, the denominator is going to 0. So it's indeterminate. But if you look at the kind of degree of these products, of these terms, the top has degree 5. So degree 1 times the degree 4, whereas the bottom has degree 4. So the top is going to 0, kind of like x to the 5th or something to the 5th power, while the bottom is going to 0 at something to the 4th power. And something to the 5th will be smaller than something to the 4th. So it looks like the numerator might win the battle here, and the whole limit could go to 0. How could you prove that? Well, in an earlier video, we saw two approaches, the squeeze theorem. So what would that look like? Since I think this limit is going to 0, if I can bound it between something going to 0, if I can squeeze it, right? If I can squeeze it above here an absolute value by something that's also going to 0, then that will show it goes to 0, right? Now, but from the squeeze theorem. Now this term would only get bigger if I added more to it. So I'm going to add x to the 4th to that term. This is almost exactly like the one in the other video. The main thing here is to kind of look at the original limit and think about the top being a higher degree product than the bottom. Right? The bottom, the denominator here is the sum of 2 degree 4 terms. Of course, now let's go back to our squeeze theorem. I can cancel those two terms, so this is just equal to the absolute value of x, which approaches 0 as x and y both approach 0. So by the squeeze theorem, the limit that we're investigating right, I'm rewriting it just to be thorough. This limit is 0. Your other approach, and I'll let you try this one, all right, I'm not going to record it here in the video, is to use polar coordinates as we did in the first video. So take x equals r cosine theta, take y equals r sine theta, substitute those for x and y, and now investigate what happens to that new limit as r approaches 0. Really, as r approaches 0 from the right, because we're thinking of r squared equals x squared plus y squared, or r is a positive number. So if you do this, you'll end up getting, I'll give you a hint, you'll get r to the 5th on top times some stuff, r to the 4th times some stuff on the bottom. The stuff here doesn't go to 0, so you just have the limit as r approaches 0 of r, and I think you can figure that one out.